Hi everyone and welcome back to my channel. I am Anish and today we'll solve the most important questions on MOSFETs. So like we have already covered op amps, we have already covered switch capacitors, and we have already covered a few important questions on diodes. So all those things have been covered. You can go and check out all those things in the playlist given in the description and in the comments below. So today we'll cover on MOSFETs. So I'll show you the questions first. You can take the screenshots and then after attending, and you can write in the comments below how many you got correct or how many you got wrong. Okay, so this is the first question, this is the second one, and this is the third one. Okay, so all these three you try to do on your own and then tell me in the comments below how many you got correct. So let's start with the first question. So this is almost like a 5-stage OT, right, with a single ended output. So what are they telling in the question? So in the circuit above, or like in our case it is in below, so I will just write this below. In the circuit below, we have to, like, all the MOSFETs are biased with a current of 5 milliampere. So they are biased with a current of 5 milliampere. That much, this much information I know, so I will write that here. So my ID bias is 5 milliamperes. Okay, now and like these are for M1 to M4, and M0 is biased with double the current, because obviously if 5 milliamperes flows through this, 5 milliamperes flows, M0 will have twice the current. So this is for M1 to M4. Okay, the rubber is too big. M1 to M4, and M0 is 10 milliamperes. Now all MOSFETs are in saturation region. They have already mentioned this. The operating bias band node voltages are provided as shown, but like we don't have to take care. If they have told saturation, then we'll assume it's saturation. The DC current through the load resistor RL is 0. Okay, when Vi is 0, when input is 0, DC current is 0. Determine the small signal voltage gain, that is Vi over Vo, if my GM over ID bias is 5 volt inverse. Okay, so this is for all the MOSFETs. All the MOSFETs have same GM by ID bias. This is a like parameter which we generally use to define MOSFETs, because this is bias independent. This parameter is bias independent. That's why this parameter is very useful for analyzing different circuits. Okay, so yeah, so we have been given GM by ID bias. From this, I know all the MOSFETs are in saturation, so I can simply replace all the MOSFETs with their own small signal models. We don't even need to do that, but obviously I need to find out the GMs of each MOSFET. I know GM by ID bias, I know ID bias, right, for M1 to M4, so I will be able to identify my GM from M1 to M4. So what will be my GM from M1 to M4? GM from M1 to M4 will be simply I like this is always 5, right? So I will just simply multiply the ID bias that is 5 milliampere. So this will be 25 millisiemens. Don't mess up with the units. And what about this MOSFET? The GM of this MOSFET, GM node, ID bias, remember, has been doubled, so it will be 50 millisiemens. Now I can simply apply the small signal, right? If I know, I will apply the small signal model, so all the DC voltages I will make them ground. So this voltage will be ground. So here only Vi will be there, but this voltage will be ground, right? 0.6 will be ground. So if this voltage is ground, correct? So obviously the VGS of this MOSFET is 0. If VGS is 0, then no current will flow. So this is a open circuit. This MOSFET will be open totally. So no current will flow through here. So, and so this, let's assume some potential here as V potential, right? Let's assume some potential Vx for now. Okay. So what will be the current that will flow through here? What is the VGS of M1? VGS of M1 is Vi minus Vx. So the current that will flow through here is GM1, or I can write GM1 into Vi minus Vx, and this is 0, right? This like this is DC, so this will go to 0. So obviously how much current will flow? This will be again GM1 along this direction, GM1 into minus Vx. So obviously I can write a KCL at this node. If I write a KCL at this node, what will I get? This will be equals to GM1 into Vi minus Vx plus GM1 minus Vx equals to 0. So what do I get? I get, this is like GM1, right? So I will get my Vx will be what? Simply will be equals to Vi by 2. Okay, this is what my Vx is. But I need to find out Vo, right? So this also is grounded, right? Because this is a DC source. Now the current through this is how much? This much, right? GM1 Vi minus Vx, that is GM Vi by 2. So the current, these two MOSFETs are in simply series, right? So current here also will be GM1 Vi by 2. And this is grounded, right? So what is the VSG of this? Because this node is grounded, so this will be ground only, okay, because it's a DC source, so this node will be ground. So current here will be GMVI by 2, GM1 Vi by 2, that will flow through here. Now some same amount of current will flow. Why? Because this is just a current mirror, because the VSG of this M4 and VSG of M3 both are same. So obviously current will also be same because the GMs are also same. So same amount of current will flow through this as well, that is GM Vi by 2, and this is GM1 minus Vx is Vi by 2. So I am telling the direction here, but the direction will be actually in this direction, correct? Because it is minus Vx, so actually the direction will be opposite, that is GM. Okay, I cannot draw the current, that is GM Vi by 2. For now I am assuming GM equals to GM1, so GM Vi by 2. So overall what is the current? Overall current through the 1 ohm resistor, this is open ended, right? I just want to find out VO. It will be GM Vi by 2 plus GM Vi by 2, that is GM Vi. So my VO will be equals to VO. I can write my VO will be equals to GM Vi by 2 into R. Basically R is 1 kilo, right? And remember this GM is in milli, so kilo milli gets cancelled. So basically my VO over Vi simply equals to GM into 1 kilo, that is 25 GM of the M1 to M4 transistor. M0, the GM of that is 50, but M0 is anyways not coming into the picture because current through M0 is 0. Okay, so this one was pretty straightforward and pretty simple question, not that difficult, and I know you would have simply solved it. Let's solve this question. This question at first seems intimidating, but actually it's not that intimidating. So how will you solve this? So again, you have to determine the small signal voltage again, that is this is Vi and Vo if all the MOSFETs are biased in saturation region. So my M0 COX WL is given, VTH, VD, all these are given. VD means what? The diode forward bias voltage. Okay, when the diode is forward bias, what will be my voltage? And VTH is the threshold voltage of the MOSFET, right? So how do you solve this? Like this seems taunting, but trust me, it is not that taunting. But this question will be lengthy. Okay, this question will be lengthy at first. So if I observe, if I want to do the small signal analysis, I know MOSFETs are in saturation, so I will trust the word. I will trust the question. MOSFET is in saturation. So if I do the small signal analysis, they're telling me capacitance is infinite. So what will I see as the impedance in AC, high frequency AC? 1 by j omega c. So omega is very high. So obviously C is also infinity. So I will see 0 ohms from here. So my Vi signal will be here. Okay. Now if my Vi signal is here, how will I identify my VO? So at small signal, this will be again short circuit, right? 0 ohms impedance. So this diode will simply be short circuited. Okay, this diode will not come into the action. Only this capacitor will be present. So basically, I can directly say the current through this MOSFET will be GMVI, GM1 into Vi. So current through this MOSFET will be GM1 into Vi. Okay, and this is infinity, right? This is infinity. So I can say like these two resistance will be simply in parallel. Why? Because in small signal all the DC sources will be short circuited. So this will be short circuited, grounded. Okay, so what will happen? This is the same point, right? This will be just a short because capacitance infinity means it will provide 0 impedance. So this VO, this impedance and this impedance both will be parallel with each other. So if these are impedances are parallel with each other, so by basically like what will be the equivalent of this? I will have a equivalent. I will just draw the circuit. This will be the RD, that is RD1 basically connected to the drain, and my VO is somewhere here. Okay, and this is the MOSFET. This is the Vi here. This is simply grounded with the help of capacitor. Okay, so basically, like this is a simple common source transistor, right? Common source MOSFET. So it will be simply GM1 into RD1. So what is my RD1? This is the gain. Obviously, don't forget the negative sign. Okay, because your current will flow like this, so voltage drop will be plus minus. So VO will be obviously negative. Don't forget the phase difference. So my AV equals to VO over VI will be minus GM1 into 20.8 kilo parallel with 10.4 kilo. Okay, so but I am stuck because in the previous question everything was simple. They simply gave me GM, but here I don't have GM, so I have to do the DC analysis. So this is the tricky part of this question. You have to do the DC analysis. So how will you do the DC analysis? Because I don't know what is my GM, right? For GM I have to do the DC analysis. So you have to go and solve the DC circuit. So in DC circuit, what happens? The capacitance behaves as open circuit. Why? Because omega is 0, 1 by omega c. So omega 0 means 1 by 0 means infinity. So this will be simply this input will be simply gone out of the picture. So I will have some potential VB here. Okay. So what will happen? Because this is 5 ohms is already here, right? So I have to identify the GM of this. How do I find out the GM? I need to find out the ID. So what is the current through this basically? How do I identify the current through this? So to identify the current, I need the voltage VB. So I will solve this circuit first. So I have to do few intuitive analysis here. So if I see that this 5 volt is connected and this diode is here. So if this voltage has to be how much? This voltage has to be greater than 5 volts, then only this diode will come into action. But am I seeing any chances? Because what will happen if current can only flow in this direction? Current can never flow in this direction, right? For this particular circuit, never flow. Okay, because this diode is obviously no current through the gate, and MOSFET can only flow current in from drain to source, right? Not from source to drain. Okay, because the diode is there also. So obviously, what I can say here is that current can only flow in this direction. So obviously there will be some drop of 5 volts, like drop from 5 volts, right? So this voltage will be somewhat lower than 5 volts. So this diode is just for showcase. Okay, so this diodes are not of any use to us. Okay, so what will happen? I will assume that the current is flowing like this. Okay, then what will be the voltage VB? Because this 1 mega ohm also is not of much use, because anyways the gate current of MOSFET is always 0, so there is no drop. So this point voltage will be same as this point voltage, no difference. So I can write the current equation of MOSFET, okay, in DC. So what is the current equation? I know what is the VGS here, because I know VD on. I have assumed that the diode is on. If the diode is on, it has a cut-in voltage. Cut-in voltage is 0.7. So this cut-in voltage is already 0.7. My assumption is diode is on, and I will prove also that the diode is actually on later on when I find out the value of VB. So this point potential is VB simply, right? So VB, I need to write the VGS. What is my VGS? VGS is VB minus 0.7. This is my VGS. But what is the current equation? Current equation, if you remember, ID is equals to VGS minus VTH whole square, and mu1 CUX into CUX W by L. W by 2L whole square. This was the current equation, right, of MOSFET, simply when it is in the saturation region. So I will write this, right? So from here I will replace the VGS in this equation, and VTH I know it's 0.7. So I will get a neat equation. What is the neat equation? That neat equation is this. So ID will be equals to whatever mu1 CX they have given me, something they have given me, right? This 2 milliampere per volt square. So I will write this in 2 milliampere for now. So assumption is I'm assuming ID is in milliamperes. So 2 milliampere per volt. This is only in mu1 CX by L. Okay, W into W by L, not 2L. So I have to divide by 2 extra, by 2 into VGS is VV minus 0.7 minus 0.7, because VTH also is 0.7 only. So many students will forget this extra 0.7. Okay, if you forget this 0.7, your answer will be wrong. So it will be minus 1.4 whole square. Now what is actually ID? What is ID here? So if I see ID, is this simple current, right? So this node potential is VB. So I can simply apply a KCL here. So ID will be equals to, from here, from this node I can say directly, this is just a current mirror, right? This MOSFET M1 and M0 are simply current mirrors. So whatever current will flow here, same current will flow. So if I am say to say the current of this ID, then this will be also the same current ID. Okay, because their VGS are same. Why? Because this diode is also there, right? And in DC this capacitor will be of no use. This will be open circuit. So this same current mirror. So ID I can write from here is 5 minus VB divided by this resistance, that is 10.4. Okay, in milliamperes obviously. So I will exactly replace that, right? I will exactly do that only. So it will be 5 minus VB divided by 10.4 equals to VB square minus 2.8 VB plus 1.56, if I am correct. So 14 whole square will be 1.56 only, or sorry, 2.56, not 1.56, 2.56, 1.4 whole square, yeah, sorry, 1.96. I'm just some other thought right now. So it will be 1.96. Okay, so now I can simply do the calculations. So this will be 1 divided by 10.4 and okay, not 1, 5 divided by 10.4, 5 divided by 10.4, and that will go on that side. So this will be plus 1.96, so this will be 1.47. so VB whole square plus 1.48, and this is 10.4 and minus 2 point, okay, not minus actually, plus 2.8. so this will be 2 point, this will be minus 2.7 VB. Okay, so you can simply solve this quadratic equation. Okay, I can also solve, but I think I have already written down the solutions. So like after solving this quadratic equation, right, you will get two values of VB. So what are those two values? So one is around VB 0.76 and or 1.94. now which one will you choose? Which value of the VB will you choose here? Okay, which value of the VB you will choose? So obviously you cannot choose 0.76. Why you cannot choose 0.76? Because if you choose 0.76, your VB has to be greater than 1.4, not 0.7. Because what is your VGS? VGS is equals to VB minus 0.7, right? So this has to be greater than VTH, that is 0.7. So your VB has to be actually greater than 1.4. So only this is the possible solution for it to be in saturation region, else it will not be in saturation region, right? This has to value, like this has to satisfy the saturation region. So obviously we will choose this one, we will ignore this one. Okay, so like after choosing VB, this what will be my ID? So like from here, like there is a formula for GM. If you remember, GM is equals to simply mu1 Cox W by L VTH, not VTH, sorry, VGS minus VTH, right? VGS minus VTH. So like I know already mu1 is W, that is 2 milliamperes, and VGS minus VTH is 1.94 minus 1.4. So this will be 2 into 0.5. Okay, so this will be almost 1. Okay, almost 1. So this is 1 millisiemens. Okay, so now I will replace this particular thing on the solution. So my gain, right, my gain is how much? AV gain is minus 1 millisiemen into 10.4 parallel with 20.8. so it will be basically 10.4 divided by 3 only. So this will be 1 into 10.4 divided by 3 divided by 10.3. This will be almost 3 minus 3.467. okay, so this will be the voltage gain V over Vi. So now, like, this was the just the difficult part of this question. Everything else is same. Everything else is very easy. Let's solve this third question. So in this third question we have, in the circuit diagram above, MOSFETs M0, M3 are each biased with a current of 5 milliampere, while M4 is biased with a double the current. So basically now, instead of it the like one of the 5, like we have 5 MOSFET, right? So the extra MOSFET, instead of it having in the bottom, we have it at the top. So M4 is at the top, and it's biased, like each of them, this M0 to M3 are biased with 5 milliamperes of current, and the M4 MOSFET is biased with what? M4 MOSFET is biased with 10 milliamps of current. So this is for M0 to M3, and M4 is biased with 10 milliamperes. So M4 is biased with 10 milliamperes, correct? So how let's solve this? So again, just same approach. So what we have to do, we have to find out the small signal voltage change. Just the same approach, right? We will apply the same approach only. So again, for small signal, I will find out the GM. Okay, I can easily find out the GM, right? So GM for M0 to M5 will be, M0 to M3 will be simply this is 10 volt inverse, so it will be 5 times that. So GM for M0 to M3 will be simply 50 millisiemens, and GM for M4 will be simply double of this, so it will be 100 millisiemens. Oh, this is 20. Okay, this is 20, not 10. Okay, my bad, I have my handwriting. So this will be 20 actually. So yeah, so this will be 100 actually. This will be 100. So, and this will be 200. Okay, so this is 200 and this is 100. Now how do I solve this? So pretty simple, right? This is pretty simple. Just apply the same principle here. So this will be grounded, this will be grounded. Okay, so obviously the VSG of this MOSFET is 0, so obviously no current will flow. Again, this will be open circuit. This will be simple open circuit. Okay, this will again not come into the picture. So GM4 is not of any use. So what is the current through here and current through here? So again, I will assume some potential here. I can assume some potential as V. Okay, so if I assume some potential V here, so the current through this will be, right? So this will be, again, this DC source will be 0. This will be VSG. So this current will be GM into minus, like this is this, okay, not minus, sorry, this is 0, sorry, V minus, I don't know this potential. Okay, I don't know this potential. Fine. So yeah, this is, although this is grounded, right? So this is grounded, so the current through this will be what? The current through this will be, this will be GM times V, right? So and the same current will flow through here as well. Why? Because this is in simply series, because current through M4 is 0. So whatever current flows from here, the same current will flow through this. So the current will be here, I can say the current will be GM V, and the same current will flow through this MOSFET as well. Why? Because they are M2 and M0 are simply in series, so the same current will flow through here as well, that is GMV. Okay, yeah, direction of current will be, yeah, something like this, yeah, GMV, yeah. So it will be GMV. But what do I know? I know the equations of this MOSFET, right? So if I write the current equation for this MOSFET, it will be GM times VGS, and VGS is VI because this node is grounded. So here it is telling me the current is along this side, that is GM times VI. Okay, so what is happening, they are both in opposite direction, so I can like directly say, or you can equate the those two. If I keep this in same direction, how do I write this in same direction? Just write minus V. GM times minus V will just make the direction opposite, so I can write it like this as well, right? This will be minus GM times V, so this will be VI will be equals to minus of V, correct? So this much information I know, and through this GMVI current is flowing. How much current is flowing through this? Because this is open-ended, right? So the same current, whatever current GMVI was flowing, same current will flow through here as well. So this same current GMV will flow through this node as well, correct? And I know one thing, right? Again I can write the current equation for this MOSFET. It will be GM times VGS. GM times VGS is simply equals to GM times VO. Okay, So VO equals to VI. So my VO is equals to VI. So what I can say is this will be simply my like VO is equals to, from this equation I can say VO is equals to V, and my V is equals to minus VI. So basically my VO will be minus VI. Okay, so VO over VI will simply be 1. We don't even need the information of GM is if all the transistors are same. If all the transistors are same, then we don't need the information of this GM, right? We don't need the information. We can simply solve. Okay, we can simply solve. So that's about it for this short video for this lecture. So I enjoyed the questions. Do let me know, and if you can send me questions on Telegram, and you can obviously avail our courses on prefusion.in. There we have like comprehensive courses for analog, digital, VLSI, and obviously for gate as well. So you can check that out. Thank you for watching, and I will see you in the next video. Until then, happy learning.